Hello, this is Mrs. Arnold, and in this video we will talk about geologic time. Questions you should be able to answer at the end are: why do scientists need a geologic timescale, and how are eons, eras, periods, and epochs defined? We are going to start with looking at the rock record. The rock layers in the Grand Canyon, which is in the picture here, represent geologic events spanning 2 billion years. So by studying layers, geologists can reconstruct Earth's history and interpret ancient environments. So I'm going to write here that geologists study, well, one of the things they do, study fossils and rock layers. And by doing so, they can reconstruct Earth's history and also interpret ancient environment. So that means that they can tell whether, for instance, an area used to be covered by an ocean. Let's say if they find a fossil of a fish in the area that is now not water, that's one thing they can tell. So that's what we mean by interpreting ancient environments. So the geologic timescale is a record of the Earth's history from its origin 4.6 billion years ago to the present. The history of the Earth is going to be divided into time units that are based upon the life forms or fossils that we find within the rock layers. So divided into time units that are based largely on fossils or life forms contained within the rocks from that era or time unit. The different time units are eons, which is the largest. Then we have second largest, which are eras, and then we go to periods. And then within periods, we have epochs. And this picture here is not to scale. And we are going to do a project that shows how little time our current era actually spans compared to the others. So our current era is the Cenozoic era, and it takes up very, very little of geologic time. So our project that we're going to do is actually going to hopefully let you know exactly how little time our current era actually spans. The largest unit of time is the eon. Eons are going to contain the other time units. The three earliest eons are the Hadean, Archean, Proterozoic eons, and these eons take up 90% of geologic time. Okay, and collectively, these eons are known as the Precambrian. So that is really important to know that. So these are the Precambrian altogether. Okay. During the Precambrian, Earth was formed during this time. And became hospitable to life. Fossil evidence suggests that simple life forms began in the Archean Eon. So, in the Archean Eon is when we get our simple life forms. And then we have at the end of the Proterozoic Eon, so the last eon that makes up the Precambrian period, we have life may have evolved by that point. To move in complex ways. So by the end. Okay. And here's a picture of a life form from that eon. Our current eon is the Phanerozoic. Okay, so eons are divided up into eras. So era is going to be the next largest unit of time, and they span tens to hundreds of millions of years in durations. And like all time units, they are defined by the life forms found in rocks. So the names of the eras of the Phanerozoic, for example, which is our current eon, are going to be named for the relative ages of the life forms. Named for the relative ages of the life forms that we find in the rocks. So, all of these eras are going to end in Zoic, which means life. What we have here is Paleo, which means old. So the Paleozoic era is going to mean old life. And then we have Meso, which means middle. So then the Mesozoic means middle life. And then our current era that we are currently in is the Cenozoic, which means recent. So Cenozoic means recent life. Eras are going to be divided into periods. Periods are tens of millions of years long, and some periods are named after the geographic region where the rocks or the fossils characterizing the age were first discovered. So some periods named after geographic region in which the rocks or fossils characterizing So example of this here, we have the Ediacara Hills in Australia. And we have the Ediacardian period, named after the Ediacara Hills, because this was the geographic region in which the rock sort of fossils characterizing the Ediacardian period were first discovered. Periods are further divided into epochs, and they are going to be hundreds of thousands to millions of years in durations. Rocks and sediments from the epochs of the Cenozoic era are the most complete because there has been less time for weathering and erosion to remove evidence of this part of history. So for this reason, the epochs of the Cenozoic era are going to be short in duration. So in the Phanerozoic Eon, which is our current Eon, Phanerozoic is going to mean visible life in Greek. This is when multicellular life diversified, and there's a lot of fossils in the rock record here. This is so the fossils are going to be more abundant than those in the Precambrian. Those in the Precambrian, there's relatively few fossils. And we also have to remember that not everything becomes a fossil. It takes very special circumstances for things to become a fossil. So very few of the organisms that have walked the planet have actually been fossilized. Many of our time divisions end with mass distinctions, which are when many groups of organisms disappear from the rock record at about the same time. Because if we remember, the time units are going to be defined by their life forms. So obviously then if the life forms, so obviously an extinction event is a nice segue into the next time unit, because those life forms have disappeared from the fossil record because they all went extinct. So many time divisions, as I said, are going to end with mass extinctions. We're going to look at the Paleozoic era. So these are the eras of our current eon: the Paleozoic, the Mesozoic, and the Cenozoic. So Paleozoic, remember, means old life. And here it's going to start with ocean life. This is where we see trilobites, land plants, and land animals come into existence. And the end, of course, is marked by mass extinction, in which 95% of marine organisms are extinct. So 95% of marine organisms during this time became extinct. Okay. And then we have the Mesozoic era, which is middle life, but it's also known as the age of the dinosaurs. And within this era, we have water-dwelling amphibians adapting to land environments. We also have insects that are thriving. And mammals start to evolve and diversify. And of course, this is probably the most famous extinction event. So there's a large extinction event at the end here, 65 million years ago. And large extinction event that happened. So non-avian dinosaurs. So remember, avians, birds, are descendant from dinosaurs. So what happened here is that non-avian dinosaurs and large marine reptiles go extinct. And then, the Cenozoic era is the rise of the mammals. And within this era, our current era, mammals dominate. Today we learned about geologic time and how we defined it. The geologic time scale, I hope you've figured out, is helpful to scientists because Earth's history spans 4.6 billion years. It can be really difficult to talk about the events that happens in each individual year. So the reason why we divide the time up into different time units is so we can just say, within this time unit, these are the things that were going on with the Earth. This was the type of life forms we can see. It's a lot easier to manage and to understand the geological events in the life that was occurring on the planet at that time if we just look at it in larger chunks than just the individual years. So that is why the geologic time scale is helpful, because it makes all of the history more easily managed. So I hope you have learned that today, and have a wonderful day and be kind to one another.